Okay, does anyone have any questions? So I'll take that as a no. And what we're going to do then is we're going to go over some problems I have from the back of the book. And as we go over these problems, you'll want, if you want to ask questions, ask them. And what I'm going to be doing is asking you, are you ready to move on? Or have you finished doing the problem or something like that? Because sometimes I'll ask you to do a problem, and rather than put you on the hook and make you tell me your answer to the problem, I'll just ask, are you finished doing it? That way your answer might be, yeah, and I can't do it. Or it might be, yes, and I've done it, and I have an answer, but I don't want to share it. It might be any number of things, but I just know you're ready to move on and ready for me to show you the problem. So give me a little signal that signifies that you understand that. Good, great. So I'm going to move this camera in my face because that's where it has to be for me to do all of this. And I'm going to go ahead and do a share. Well, it's not working. I have to go back in and set up the camera. Hang on a second. Let me turn off the camera and turn it back on. That may be what I have to do. Okay, we'll try that. This will take a little bit of time. Hopefully not too long. And it should pop up here in just a moment. Okay, I've got it working on my end, so now let me share that with you on your end. So I've got to go to Zoom, choose a share screen, go to Elmo, and here we go. So here's the problem we're looking at. This is just a reminder of what we finished off on yesterday, where we were finding accuracy and precision for this to compare which one is more accurate and which one is more precise. So just a quick reminder, the average value and percent error, the percent error was used to determine which one was more accurate, smaller percent error, more accurate. And for precision, we used range and we used average deviation to see which one was more precise. And in both cases, smaller range, smaller average deviation, more accurate. Okay, so let's take a look at the next problem here. Express the following numbers in fixed notation. So you can see that fixed notation means no 10 to some power. And I'm going to explain to you how I go about doing this, and it's pretty simple. You look at the power. If the power is positive, you take the number part and make it bigger. When you make that bigger, you're incorporating the 10 to the third. So how much bigger do I make it? I make it so that I move the decimal over 3 places bigger. If I move the decimal to the left, I'll be making this number smaller. But if I move the decimal to the right 1, 2, 3 times, because the power is 3, I will be making it larger than that number. But because we're incorporating that number, this number is equal to that right above. So the deal is that if you have an exponent and it's positive, you make n larger. And if you have an exponent and it's negative, you make n smaller. And when I talk about n, this is scientific notation, and I write it this way. N is this part, and 10 to some exponent. So that's how you do it. So that's A. Let's take a look at B, 2.57. So this exponent is negative. I'm going to make n smaller, which means I'm going to move the decimal over 1 place, 2 places, 3 places, and 4 places. And that's where it's going to end up. So I'm going to make that a big dot there. And when I write that, I write dot 000257. And I like to put a 0 in front of the decimal. It actually makes the decimal stand out better. And this is equal to the number above. So I'm going to ask you quickly, does anyone have any questions about that? Or let me ask you a different question. Is everyone okay with this? Now, this is a problem where I'm not going to ask you to show me the work. You're just going to get it right or you're going to get it wrong. So I want you to do the same for letters C and D and turn those into fixed notation. And when you're done, give me a little signal that you're done. Like a yes or a no or a thumbs up or a clapping hands or go faster, go slower. This number down here is 3.404. And remember, you're going to signal me that you're done with this problem. And when you're done with it, it may be that, well, you know what, I have another question about it, but I'm going to show you how I figure out the answer. So really, you're telling me you're ready to move on. Okay, so we've got a couple. I've written the two numbers down here for C and D. And I've taken the liberty of writing just the number part of C. And the idea here is if that's a -2, I have to move the decimal over 2 places. I want to move the decimal over 2 places to make this look smaller. So that's 2 places. So it's going to be 0.0632. And that's a perfectly fine answer. If you put a 0 here, it's the same answer. For D, since this is 3, I want to move the decimal to make this look larger. So 1, 2, 3, and I'll have 3404. Now, one of the things I want to point out to you when you do this, regardless, your fixed notation versus your scientific notation, they will both have the same number of significant figures. Here, 3 significant figures. Here, 3 significant figures. Here, 4 significant figures. Here, 4 significant figures. Here, 3 significant figures. Here, 3 significant figures. And you need to remember that leading zeros don't count as significant figures. Okay, so we're going to move on. The next problem makes us practice carrying significant figures through calculations. So in the first three calculations, they are all multiplication division. So that's all we use, the rule for multiplication and division. And the rule for multiplication and division is that however many significant figures you start with, your answer has the same number as the beginning number with the fewest. Now, in all of these cases, we have only one beginning number. And this number has three significant figures, so we need to end up with three significant figures. Same for this, and same for this. So they'll all end up with three significant figures. We'll work on D a little bit later. So what I like to do when I'm trying to figure out these answers, though, is I like to do a little estimating. So if we have 6.25 times 10 squared cubed, the way I think about this is that we have 6 times 6 times 6 times 10 squared times 10 squared times 10 squared. I'm estimating. 6 times 6 is 36. 36 times 6 is 200 something. Let's call it 220. 10 squared times 10 squared times 10 squared is 10 to the 6th. And if we write this in scientific notation, it's 2.2 times 10 squared times 10 to the 6th. So we get 2.2 times 10 to the 8th. And that's my estimate. Now, what I want to do is I want to show you how to enter this number into your calculator so that you can do this fairly easily. And what I'm going to do here is I'm going to zoom in. And hopefully you can see my calculator. I'm going to turn it on. And when I see a number in scientific notation like this, I use this button right here. And let me focus. Okay, at the tip of my pen, you can see an EE there above my x to the -1. I like to use that button for scientific notation. So I type in 6.25, and to get that EE button, I hit the second button, EE. And the thing that always confused me is it says EE here, but it only says E there, like it lost an E somewhere. I don't know. And for the 2, I put a 2 there. Now, if it were a -2, I would use this negative button first and then -2. Okay, so I want to raise all of this to the 3rd power. And a very convenient button for raising stuff to some power is this here, which a lot of people call the caret. So you push the caret button and you push 3. And hopefully this will come out to be like 2.2 times 10 to the 8th. And let's take a look. And you can see we get 2,000 or 24414. I don't know if that's 2 times 10 to the 8th or not, but I can check. And so let me show you how to turn this into scientific notation. And this is also kind of a clever way to change things from fixed notation into scientific notation, vice versa. So if you look at the label above this DRG, it says Sci Engineering. So if I press second Sci Engineering, I get flow, Sci, and engineering. Flow means fixed notation. Sci is scientific notation, and engineering is engineering notation, or ENG. So I'm going to use my little, I'm not sure what you call these keys, but the direction keys. I'm going to scroll over to science, and I'm going to hit enter. And notice how it changes that into scientific notation. So my answer is 2.44 times 10 to the 8th. Now, let me show you another way to do this. And this is going to end up being wrong. So I'm going to put 6.25 times 10 to the caret 2. So a lot of people like to use the caret for any 10 to some power. Now we're going to raise this to, we're going to cube this. So I'm going to go ahead and put caret cube, and let's see what happens. We get 6.25 times 10 to the 6. So something's not right about this. To make this work, I actually have to use parentheses, 6.25 times 10 caret 2, end parentheses. Now I can use caret 3, and I get 2.44 times 10 to the 8th. So what I'm trying to teach you here is that if you use that EE button, it puts parentheses around that automatically. Plus, you don't have to write 10 to caret 2. You can just write E2. So I'm going to show you the scientific, or the EE button again. 6.25 second EE2. So the way you would read that is parentheses 6.25 times 10 to the second power, end parentheses. That's what that represents. And it doesn't take many keystrokes to do it. So I use it because I don't need to worry about parentheses for that particular part of the problem. So are we good to go? That's a yes or no. We good to go? There's a question. Go ahead, Izzy.
Just very quickly on the test, like, do we have to show all that work, or can we just like put it in the calculator and just be like, this the answer?
The answer to your question is this. Let me back out of this. If I give you something like this on the test, I want the answer with the correct number of significant figures. And I don't want to see how you used your calculator. It's your responsibility to be able to use your calculator correctly. Okay, so the answer to your question is, I'm not going to ask you to show the math work, but when it comes to manipulating equations, I may ask you to show that work. Okay, so especially like with conversion factors, I expect to see the work, not just the answer. We're going to see a problem later today where we use percentage, and a lot of people are taught to use percentage a certain way in math, and it's not good. I'm going to teach you a better way so that people understand your logic. Whereas when you use percentage, you often don't use logic. You just use move the decimal over. So in this case, I would just expect the answer. Okay, Izzy?
Yeah, okay, sounds good. Actually, that reminded me of something. I don't know if you could go over for the law of definite proportions when we're doing like those type of questions, like how you want us to show our work. Because when I was doing it in the assignment, I think I was just kind of like doing it intuitively, like this, but I'm not sure how exactly you want us to show our work, I guess, in some of those questions.
One of the law of definite proportions was that you have 2 grams of hydrogen and 16 grams of oxygen for 18 grams of H2O. Okay, so these are the proportions. And the question was, well, suppose you had 27 grams of H2O. How many grams of hydrogen would you have? Okay, so we want to turn this into grams of hydrogen. And you would start with 27 grams of H2O, and you would multiply by something that had grams of H2O in the bottom and grams of H2 on the top. And we would look for the numbers that belong here based on these equalities. You can see for 18 grams of H2O, you have 2 grams of hydrogen. So this is what the work would look like. And then you would finalize the answer. Now, one of the things I didn't like about what the book did is that this is only one significant figure. So we only get one significant figure over here, and that turns out to be 3 grams of H2. So can you see how the grams of H2O and the grams of H2O cancel? And we get a nice little answer here. Now you can see that if we do this, H2O times 2 grams of H2 over 16 grams of oxygen, nothing cancels as far as the units go. So when we do this, we're going to get one significant figure, and let me clear my calculator. 27 times 2 divided by 16 comes out to 3. So we get 3 grams of H2O, grams of H2 over grams of O2. And that's hardly what we wanted if we wanted grams of H2. So I don't know if this helps you with what I'm looking for, but if we were trying to figure out the grams of H2, this is what you would show.
Yeah, that's basically just what I wanted, is to see exactly how you want us to write it. Because when I did it, I kind of did it more like I didn't do it exactly the way you did it right now. I just did it my own way, and then I was like, wait, I
So
probably have to write it a certain way.
In your way, was it obvious that you were switching between, say, H2O and H2?
No, yeah, I think that's why I wanted to see how to write it correctly and show that, you're taking it from the H2O and the H2O and canceling that out. I just kind of did cross multiplication and it got really messy, and I was like, okay, I got the right answer, but it's not like the best way of writing it.
You did something like this: 27 grams of H2O over 18 grams of H2O is equal to 2 grams of H2 over X grams of H2. Something like that.
Yeah, I did cross multiplication, which like it gave me the same like result, but it wasn't like the way you wrote it. And I had a feeling that that's how you wanted us to do it, like the other way. Yeah.
If you show me something like this, here's the work I would expect to see. Something like this. And then you can see that these cancel. And you can see that these cancel. And then you get X is equal to 27 times 2 divided by 18. And then you get X is equal to 3. And then you have to say, oh, 3 grams of H2. So there's a whole lot you got to show if you do this. And this is a great way to work if you're doing algebra. It's not so hot if you're doing intermediate algebra. And it's far harder to understand than if you look at this. Chemistry is a way of communicating how you're making those calculations, where people should be able to see where things are canceling. Plus, whenever you see a conversion like this, you're automatically saying as a chemist, oh, 2 grams of hydrogen is equal to 18 grams of H2O. And we're not saying that they equal, we're saying that you get 2 grams of hydrogen out of 18 grams of H2O. Okay?
Right, exactly. So, it's just another conversion rate. And I guess in my head, I was just kind of doing my own thing.
Yeah. Proportions are for, proportions are just the way they teach you in math at first how to do things. They should really teach you this, because you learn a whole lot more this way, and you learn how to think about things and communicate things better. Whereas I think this is the easy way out.
Yeah, it's way better that way. It's much neater.
Yeah, this is, I mean, that's just beautiful up here. This is a mess.
Yeah, that's how I felt. Like, I feel like I should just do it more neatly.
Yeah. So on these problems that we're talking about now, you just get the answer. So let's go back to the problems we're looking at. And you can see the next problem, we're looking at 2.35 times 10 to the minus 3 and the square root of that. Now, I don't know if you guys remember this, but when you take the square root of something that's smaller than 1, because this is smaller than 1, it has a negative 3. When you take the square root of something like 0.01, it's actually 0.1 times 0.1. The point is that the answer is bigger than what's underneath here. So when we do this problem, we should get a number that's bigger than this. So I'm going to show you a couple of ways on my calculator for how to do this. So one of the things I'm going to write here is that this is the same as 2.35 times 10 to the minus 3 raised to the 1/2 power. When we say square root, that's the same as 1/2 power. And you can't see what I'm writing, so I'm going to scoot things over a little bit. So these mean the same thing. And so here, what I'm going to do is on my calculator, I'm going to type in 2.35 second EE, and I'm going to hit the negative button so you can see the negative sign there, 3. And then I'm going to do caret, and I can either do caret parentheses 1/2, or I can do caret 0.5. I'm going to go ahead and do the parentheses 1 divided by 2. And you can see we should get a number that's bigger than 2.35 times 10 to the minus 3. And we get 4.84 times 10 to the minus 2. 3 significant figures. And actually, we want to round the 4 to a 5 because it says 4.847. So there's the answer for that one. And the way to check the answer is to square this. If we square this, we should get what's underneath. And when I hit the square button, you can see I get the 2.35 again. Okay, let's move on to this next one. 2.35 times 10 to the minus 3. Do you see how I can do this problem the same way I did this problem, the same way I did this problem, only here I'm going to put caret parentheses 1 divided by 3. So give this one a shot and give me a little signal that you're done, and then I'll do the work on the calculator and we'll see if we get the same answer. Has everyone found their EE button on their calculator? Okay, we've got one who's ready to move on. And we've got 2, so we're going to go ahead and move on. So 2.35 second EE negative 3. And then I'm going to raise this to the 1/3 power. Let's see what happens if I don't use parentheses for my 1/3. 1 divided by 3. So remember, we're looking at a number that multiplied by itself 3 times will get this value here when we say to the 1/3. Okay, so that means it should probably be something like I don't know, 1.2 or 1.1 times 10 to the minus 1, something along those lines. And if I do this, I get 7.8 times 10 to the minus 4. This number is smaller than the number in parentheses, and the number should be bigger. So now let's try this again. 2.35 second EE negative 3. And I'm going to raise it to the parentheses 1 divided by 3. And we get 1.3 times 10 to the minus 1. So this is what we expect. How many significant figures are we allowed? And the answer is 2, 3, and 5 are significant. So we're going to keep the first 3 numbers of this, 1, 3, and 2. But when we look at the 2, we look at the number to the right and ask, should we round the 2 up? And in this case, we should definitely round the 2 up, and we get 1.33 times 10 to the minus 1. Any questions on this one? Okay. There is a question. Izzy.
I got something different. I got 0.13.
You got 0.13, but take a look at my number in the calculator. You see that? Now, I'm going to change this to fixed notation.
Oh.
And you can see 0.13 and 1.3, and you got 0.1329, right?
Oh, yeah.
They're the same thing.
Yeah.
So what that tells me is that you just need a little more practice to work in your mind what the 10 to the minus 1 means, okay?
Okay.
So this next one, we actually have to use a subtraction when we're trying to figure out the significant figures. So what I want you to do is work out this solution, get the answer, and report the correct number of significant figures. And while you're doing that, I'm going to pause this because it'll take you a little while to work this out. But when you're done, give me some sort of a signal, and then we're going to compare I'm going to show you the work, show you the right answer, and explain why that is. Anurag, you have a question.
Yeah, so on my calculator, there isn't a DRG.
I don't know what DRG means. I'll be honest. I'm looking for the one that says science engineering. I don't know what calculator you have.
It's a scientific calculator.
Oh, that doesn't matter. Every scientific calculator, depending on the maker, is set out as a little bit different. So that's why I recommend people get this calculator, because this is the one I use in class. It's the one I'm going to be using on the videos, and it's inexpensive. So what you might want to do for your calculator is go to the internet, type in the model, and say, how do I change from fixed notation to scientific notation? And it'll tell you what to do. But you don't want to do that in the middle of a test. So I would find a calculator that you know how to use pretty well, or get one of these and learn how to use it as I go through it.
All right, okay.
Yeah, and again, I have no idea what DRG means. I've never had to use it. Okay, so I'm going to let you guys work through this. I'm going to pause the recording because we don't want to record to hear my spiel again. All right, so let's go back to this problem here. So just a quick recap. 21.26 is the difference between 23.56 and 2.3. When you plug these numbers into the calculator, you get 0.028619. The most common answer I get for this one, from students is 0.029, because they think 2 zig figs here means 2 zig figs here. And that would be wrong. So right here, if we do this 1.68, the difference between 23.56 and 2.3 is 21.26, which is right there. And if we were to round right now, it would become 21.3, but we don't round yet. And I'm keeping track of where I should round that to. And the next operation here, we have 3 significant figures, 4 significant figures. And even though we show 4 here, this really only represents 3 zig figs. So our answer when we multiply and divide is to use the number of significant figures of whichever starting number has the fewest. So we get 0.0286, 3 zig figs because of that and that. And the reason we don't round the 21.26 early is because if we do something like that, there is the chance that it might bump the number up a little bit, because this is larger than that. And our answer might end up being a little bit larger than it should be. So that's why we don't round early. So with that being said, here is your new problem. And when you're ready to go, give me a little thumbs up, and I'm going to go ahead and pause the record. So naturally, I'm going to do what's inside the parentheses first, and I'm going to do the subtraction first. So this becomes 1.68. And the difference between these two is 0.02. And this is good to the 100th, and this is good to the 100th. So that means this is good to the 100th. Now, at this point, I'm doing just multiplication and division. So I know this has 3 zig figs. I know this has 1 zig fig, and I know this has 4 zig figs. So I'm going to report my answer with 1 significant figure. So let's see what we get. And I get 0.00003. If I put this in scientific notation, I get 3 times 10 to the minus 5. Those are the same answer, and 1 significant figure is the end. Any questions there? Okay, we're going to go ahead and move on. Now, these problems here, you can see that it says refer to the book. And the reason is because I'm not writing out these questions. I have someone helping me with that. And I told them if the question's really too long, skip it. So we're going to skip that. So let's take a look at this one right here. I'm going to pause the recording, but what I would like you to do is solve for n. Find out the value with the correct number of significant figures. When you're done, give me a little signal that you're done, and then I'll show you how I would do it. But ultimately, for this particular problem, I would just expect an answer. Recording. So what I'm about to show you, you wouldn't bother showing me on a test, but you're going to divide this side by 0.0821 and 273. If you're going to do that to this side, you're going to do the same thing to the other side. So these cancel, and you get n is equal to these two numbers divided by these two numbers. I'm going to show you the quickest way to put this into your calculator and get the correct answer. So here's my calculator. I'm going to turn it on and clear it. So the way I put this into my calculator is if we have A times B over C times D, you put it into your calculator like this: A times B divided by C divided by D. And I know that the answer here is going to be about 1.5. And the reason I know that is because I estimate. 0.08 is really close to 0.1. Not quite 0.1, but close to it. The reason I like to think of 0.0821 as 0.1 is because 0.1 is 1/10. 1/10 of 273 is 27. Now, naturally, since this isn't really 0.1, this isn't really 27 when we multiply it, it's less than 27, but it's close to 27. And I'm going to pretend that it's not 27, but it's 23.4, which is close to 27. And the reason I'm doing that is because if I have 2.34 over 23.4, that's the same as 1 over 10. And 10 goes into 15.6, 1.56 times. So that's my ish. I think the answer should be around that. So I'm going to put 2.34 times 15.6 divided by 0.0 821 and divided by 273, and I get 1.63. So there's the answer. 3 significant figures because of this, 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 and this. They all have 3 significant figures. Now, another way to put this into your calculator is as follows. A times B, and put parentheses around that. Put divided by, and then C times D. That's another way to do it, but it takes more keystrokes, and that's why I don't do that. Now, how should you do this on the exam? And the answer is whichever way you're most comfortable with. Capiche? That means okay? Okay. So let's move on. This one, I'm going to have you do on your own, and you're going to ask me about it tomorrow. And here's the things I'm going to tell you about this one here. The minus 246 has 4 significant figures. The 1312 has 4 significant figures. The 1 has an infinite number of significant figures. The 2 has an infinite number of significant figures. The 1 has infinite number of significant figures. I want you to calculate the value of n with the correct number of significant figures. So that's like a little homework assignment for tomorrow. I'm going to give you a moment to copy this down, and then we're going to move on. Because there are 2 problems I'd like to do before the night ends. So give me a little thumbs up when you're ready to move on. And you don't need to copy all of this if you don't want to, because you can always look at page 52. But let's move on. So this is a little bit more of the conversion factor method. In this case, we're not going to do angstroms because chemists don't usually do angstroms, but physicists do. So we're going to convert 0.154 nanometers to meters. And I want you to recall that nano is equal to 10 to the minus 9. So that means if you have 1 nanometer is equal to 1 nanometer, then 1 nanometer is 1 times 10 to the minus 9 meters. So this is my equality. And if I go 0.154 nanometers, I'm going to take one side of this equality and put it in the denominator. And I want to take the side here and put it in the denominator so that the nanometer cancels. So naturally, I'm going to put 1 nanometer here and 1 times 10 to the minus 9 meters here. And when I work this out without my calculator, I get 0.154 times 10 to the minus 9 meters. And this is a perfectly valid answer. Now, one of the things you'll notice is that this answer is not in decimal form or fixed notation. It's also not in scientific notation because it's not 1.54. So how can I get this into scientific notation? All I have to do is plug it into my calculator, 0.154 second EE negative 9, and put equals. And now it's in scientific notation, 1.54 times 10 to the minus 10. Would I do that on the test? And the answer is no. The reason I wouldn't do that on the test is because if there's a way to mess something up, I'm going to find out a way to do it. And this problem does not ask for scientific notation. It does not ask for fixed notation. It just asks for the answer in meters, and this is valid. And of course, there is an easier way to do this first problem, and it's this way. 0.154 nanometers is 0.154 N, really means 10 to the minus 9 meters. You can see this answer is the same as the one above, and all I did was substitute 10 to the minus 9 for nano. Any questions about this one? Yes or no? We got one no, two no's, so we're going to move on. Now, to turn it to picometers, I'm going to do 0.154 nanometers to meters and then to picometers. So I know that, like above, 1 nanometer is 1 nanometer. So 1 nanometer is 1 times 10 to the minus 9 meters. I'm going to write 1 picometer is 1 picometer. And therefore, 1 picometer is 1 times 10 to the minus 9 meters. So I'm going to circle these, and I'm going to use them in my calculation below. So which side am I going to put in the bottom? 1 nanometer, and the other side on top. And the reason for that is that the nanometers cancel. Which of these am I going to put in the bottom? And the answer is I'm going to put 1 times 10 to the minus 9 meters so that the meters cancel. And I'm going to put 1 picometer on the top. And we will end up with picometers. And oh, I made a mistake. This should be 10 to the minus 12. So correct that. 1 picometer is 1 times 10 to the minus 12 meters. And if you knew that and let me start this problem without correcting that, shame on you. You got to say something. So here, 10 to the minus 12, if I put it in the numerator, it becomes 10 to the positive 12. 10 to the positive 12 times 10 to the minus 9 is 10 to the positive 3. So this is 100 or 0.154 times 10 to the 3 picometers. And of course, you could write this as 154 picometers. Any questions about this one? There are other ways of doing it, and this isn't the only way, but as long as what you've written out has units in it and the top equals the bottom, that's going to be fine. Okay, so the last problem I want to do tonight is this one. And the reason I want to do this one is because they teach you a certain thing in math that is a trick and not a very good way of doing it. So everyone see this platinum containing drug called cisplatin has 65% mass percent of the metal. Platinum is the metal. The other elements in the drug are not metals. If you have 1.3 grams of the compound, what mass of platinum is contained in the sample? So some people do this, 1.53 grams times 0.65. So how did I get the 0.65? Most people know that when you have a percentage, you move the decimal over 2 places. So we get 0.9945 grams. Based on what I've done here, what would I write as my correct answer with significant figures? Chances are you'd say, well, I need 2 significant figures here. So I need 2 here. And therefore, I'm going to keep the 9 and the 9. And since that's a 4, We're going to leave it at that. And this is not quite correct. So let me show you why it's not correct. It's really 1.53 grams times 0.650. So we forgot about that zero there. So we actually need 3 significant figures, and we get 0.995 grams. Now let's take a look at this. This basically says that 1.53 grams is 0.995 grams, which doesn't quite make sense. So I'm going to show you the proper way to use percentages in this class. And this is the way I want you to use them from now on. Percentage means, X percentage means X over 100. And not only does it mean X over 100, it means X part over 100 whole. So in this particular problem, we're talking about X grams of platinum over 100 grams of cisplatin. Okay? And specifically, it's 65.0 grams of platinum over 100 grams of cisplatin. And I want you to do that for percentages from now on in this class, because this is much more informative than this over here. There's another reason why I have you do this. A lot of people, when they take this and they turn it into a fraction, so they get rid of the percentage, half the people will write this, and this is incorrect. The correct answer is so how do I know I'm supposed to move the decimal to the left? And I'll show you why I know I'm supposed to do that. This percentage really means over 100. If I divide this number by 100, do I make this number on top smaller or bigger? The answer, I make it smaller, not bigger. So that's the real reason why you move the decimal to the left, not because that's what you were taught to do, but because you're dividing by 100. So let's use this and this 1.53 grams of cisplatin. And let's use this fraction here to solve this equation. Now, this has 3 significant figures. This has 3 significant figures, and the 100, because that's a definition of percentage, has infinite number of zig figs. How many significant figures are we allowed? 3, 3, infinity. We're allowed 3. So if we take a look at the 2 solutions, which one is more convincing that there are 0.995 grams of platinum in 1.53 grams of cisplatin? The top or the bottom? And the answer is this is much easier to see how things cancel and why grams of cisplatin turns into grams of platinum. So this is the way you might do it in a math class. It's not allowed in my chemistry class. I want you to put it over 100. So what does 52% mean? Write it out, and when you're done, give me a thumbs up. This is one of those things where I'm not moving on until we give all thumbs up. What's 52% mean? Okay, so we've all responded. You should write 52 over 100. And if we say 52 mass percent, we could write 52 grams over 100 grams. We could write 52 pounds over 100 pounds. We could put 52 stone over 100 stone. What do all of these units have in common? And the answer is they're all mass units. A stone is an English unit that they use to measure people. It's about 14 pounds. So if you weigh 140 pounds, you're about 10 stone. It's kind of weird, I think. But at any rate, notice that the top unit matches the bottom unit. If it were 52 length percent, that would be 52 millimeters over 100 millimeters, or 52 meters over 100 meters, or 52 yards over 100 yards. And so you can see that if we start putting it over 100, we can see how we can convert from, say, millimeters of hair to millimeters of, I don't know, book. I don't know why you'd be comparing hair and book, but you can compute or convert between different things when you start doing this instead of just doing that. So that's your introduction to that percentage thing, and you want to be aware of that. And that's how I want you to do things. And so what you might want to do is take a look at this problem again. And even though I showed you the solution, see if you can come up with the same solution I did without looking at my solution. And if you can't, you're not ready. If you can, do it again until you start feeling more comfortable with it. That's the only way that's going to work, is do it until you feel comfortable with it. Izzy, go ahead.
So essentially we can just, create that 100 in any like question that resembles like a percentage of anything.
Any percentage, because percentage means over 100.
Right.
It numerically is defined as over 100. It's the thing to do. And that way you don't have to remember which way to move the decimal. For the longest time when I was younger, I was trying to how am I supposed to remember to move this to the left or the right? I got too many other things to worry about.
Yeah, it also makes it clear to keep track of it.
Absolutely. And that's why I tell people, if you understand the definition of something, it's much easier to work with than if you're just told, just do this. I mean, how many times have your parents said, look, I don't want to explain it to you, just do what I tell you to do. And you wanted to be told, but why? Why do I need to eat that nasty broccoli? And the answer is because it's good for you. So often we find that we don't really understand that till we're my age and we're in bad health because we didn't eat that broccoli. Okay. I know I'm not that in bad health. I'm just not in great health. I wish I'd eat my broccoli. I love broccoli now. Didn't like it back then. But that's for another time. So we're at the end of the time. I'd like you to go ahead and turn on your mics just so you can say goodbye to everybody.
Bye.
Bye, everyone.
Goodbye.
Bye.
Hopefully I'll see you again. Okay, bye-bye, toodles.
All right. Have a good night. Bye.
Good night.